Hello everyone, welcome to VMAC1114. Last time we already talked about how to establish trigonometry function by using trigonometry ratio. We also talk about a very special number, we call it period, right? The period is the number when we add or subtract by 2k pi. And when we add or subtract by 2k pi, I say that the function can be shifted to the left or to the right, because when you add or subtract to the argument of the function will be shifted horizontally. We already learned transformation of function in college algebra. Now, if we go ahead and keep adding 2k pi, okay, k is from 1, 2, 3, 4, 5, okay, what is happening is going to be the domain of the function will be changing, of course, right? And how it's changing. So in this video, we'll be discussing more about trigonometry function. We'll be talking about a domain of the parents of our trigonometry function, okay? And we also talk about the range. Besides, we'll also be discussing more about the period number. So how we're gonna calculate the period number, okay? So let's get started. So again, I'm gonna put the topic today will be trigonometry function. Okay. All right, trigonometry function. And the first function I want to talk about is the sine function. Sine function. Okay, I will be talking about the parent of the sine function. Then I will be talking about the sine function after transformation. Okay, so first, part A, parents function. Okay, and the parents function of sine function will be look like this: f of x. Oh, I'm sorry. Let me use different color. F of x. Oops. F of x equal to sine of y. Okay. Okay, so this is the parent function of sine function. Okay. And let's see the graph of this function look like. And based on the graph, we can find our domain and range, right? Alright, so I'm going to use the very traditional method of graphing this one. So I'm going to use the table. I set up the table and plug in the point, the value. Before I do that, I just want to remind you that the x, okay, the x over here, the input over here, x will be in term of degree or radian. Okay. So I'm going to use the radian unit to graph this. So I'm going to go ahead and set up the table. So this is x over here, and this is sine. Okay. Now let's start with the x equal to 0. Okay, x equal to 0, sine of 0 is 0. Okay, we already know that because you look at the unit circle. Remember the unit circle we learned last time? Or you have to memorize the table. So either way, okay, you gotta memorize it. So this is sine. Here's cosine. So 0 degree. This is 0 degree right here. Just imagine this is initial sine. The terminal sine is on the same is on the x-axis. So this 0 the radian, sorry. So it's 0 radian. So this sine will be 0. This is 1, 0, negative 1. Alright, so 0. How about pi? pi. Pi is here, right? Pi is here. Pi is the 180 degree. So it will be also 0. Huh? We also 0. Then how about pi over 2? So I just evaluate some special angle right here, quadrantal angle. Okay, so pi over 2 here will be 1, right? Because this pi over 2 is up here. Just imagine it's rotated. So up here is 1. And 2 pi. Oh, how about 3 pi over 2? 3 pi over 2. This is pi plus pi over 2. So 3 pi over 2 will be -1. Then we have 2 pi will be 0. So I just go ahead and find a value for 1 revolution only. So you start from here and you go back to here, 1 revolution. Alright? And I'm gonna go ahead and sketch them. So let me use let me see, I can use different, I think I can use the white color to sketch it. Alright. Okay. Alright, so we have 1, -1. So this is 1. It's just -1. And because I just sketch 1 revolution. 1 revolution. So let me see, let me get a pen right here. I don't have any pen here. Okay. Alright. Okay. So I'm going to just go ahead and sketch 1 revolution. With me now, you go from 0 to 2 pi. So I'm going to mark over here. It doesn't matter. It's mark over here 2 pi. And half of them will be pi. And we have pi over 2, which is here. And we have 3 pi over 2, which is right here. Just a sketch, okay? So when then we have 0 here. So when I have 0 radians, so it's going to be 0, so you're going to start from here, right? Then at pi over 2, we're going up here, right? And we have pi, you go back to 0. And 3 pi over 2, go to -1. And go back to 0. Alright, so the sketch of sine function will be something like this. There you go. Alright. Alright, so this is the shape of sine function for 1 revolution only. For 1 revolution. And just imagine if you go ahead and shift it to the right, right? 2k pi, when k equal 1, right? It will be 2 pi. When k equal 2, k equal 2 will be 4 pi, right? So you shift the whole thing right here to the right. So when k equal -2 will be -4 pi. Now you keep doing that. Just imagine. If you keep doing that, what do you have? If you keep doing that, you're gonna have the shape over here to keep going to the right and keep going to the left, right? So by observation, we can determine the domain. In that case, the domain will be go from -infinity to +infinity, of course, right? Because you keep shifting to the right. Right? Or you can think this way: if you keep going up, if you keep plugging the value, some special value, for example, or the next one will be 2 pi plus pi over 2, right? It will be 5 pi over 2. If you plug 5 pi over 2, you you evaluate the sine function. At 5 pi over 2, you will see that it's going to be up to 1. Okay, so the value over here, the table I give you here, just for 1 revolution, and I keep evaluate the sine at some special angle. Like I keep going forever. then the sine function is going to go all the way to the left and go all the way to the right. And that's why the domain will be negative infinity to positive. Okay? How about the range? The range is not changing. The range is not changing. No matter what the value of x over here, you plug it in, the range is always go from negative 1 to 1. Included. Alright? So that is the domain and range of sine function. Negative infinity to positive infinity. Okay? And negative 1 to 1 included. Okay? Now, last time we said that if we add or subtract 2k by 1, k equal 1, k equal 2, k equal 4, right? K equal 4, and so on, and it starts shifting. It starts shifting. All right. And we know that the value we added is, we call that a period. So what is period? What is period? Graphically, if you look at the graph, the period is nothing but is nothing but a revolution. It's a revolution. It means that the period is nothing but from here to here, 0 to 2 pi. 0 to 2 pi. It's a distance you travel from. Graphically, okay, graphically, this is the when you travel from 0 to 2 pi, you go up like this and go down like that, right? Then that is the period. Okay. And physically, what is period? Okay, period. So graphically, okay, so this is graphically. Period, I call the p number, is 2 pi, which is 1 revolution. That's why we call the sine function is periodic function, because it's repeated by period. Okay, I mean when k equal 2, it'll be 4 pi, right? You're gonna shift it to the right, right? Everything, just imagine everything we shift it to the right. It's gonna repeat one more time, and it keep repeating. That's why we call it periodic function. Okay, and the period over here is nothing but it's 1 revolution. When you go from 0 to 2 pi, you go up and go down, graphically. But physically, what is period? Physically. Period is the length of time to complete. So this is length of time. Or I can put it's the amount of time. I think that's what this will be better this way. Okay, this is amount of time. To complete 1 revolution. Okay, or one cycle of motion. It's the amount of time to complete 1 revolution. So this is nothing but the t, right? It's nothing but t. And we already know, everybody know that t equal to what? T equal to, we know that d equal to RT, right? D equal to RT. So t will be d over r. So in this case, we can calculate the amount of time will be p equal to what? D equal to RT. Remember this? Remember that d equal to RT. D equal to RT, everybody know this formula. So T could be D over R. D over R. And D is what? D could be, as I said graphically, D is when you travel from 0 to 2 pi. So up here is could be 2 pi. R is the radius, which is the speed when we talk about linear velocity. It's a V, you know. But when we talk about a circular motion, the speed is an angular speed. You remember that? So we tell the difference between angular speed and linear speed. So the R in this case will be omega. So this formula will help you to calculate the amount of time to finish 1 revolution. P equal 2 pi over W. Okay, so P over here is if over here the unit over here will be radian over second, then over here will be second. Okay, and P equal to pi graphically, this is go from here to here. The period, it means you go from 0 to 2 pi. Okay. Now another quantity is very important. That's also related to periodicity. When you set it up, when you make it reciprocal of the period, okay, of the period, we have another quantity we call the frequency. Frequency. Okay, so frequency is notated as f equal to, okay, and you set it 1 over p, which is omega over 2 pi. There you go. So frequency, and then the unit for frequency is hertz. You know, we're gonna talk more about this when you take Physics 1. Okay, but it's good to know at this time because it lets you tell the difference between the period in terms of graph and the period in terms of time. Okay. So the frequency, literally, it is the number of revolution, okay, per unit time. So it tells you the number of revolution for 1 second. That's what I mean, or the number of revolution for 1 minute, something like that. Okay, that's what frequency means. Okay. Now in this graph we also have a very nice information over here. So we know the range is from -1 to 1. So it's bounded vertically at -1 and 1. So the value from 0 to 1 over here, okay, the distance from 0 to 1 or from 0 to -1, we call it amplitude and we call it A. So we call it A. So A is absolute because it's always positive. This the distance from 0 to 1, or this from 0 to -1 is always positive. So we call it amplitude. Okay, amplitude. And if the amplitude is the absolute of the amplitude, which is the amplitude is greater than 1, so we know that the graph will be steeper. Just think about it, when A equal over here, the A is the value, the amplitude is over, actually the A is right over here. See the invisible A, right? So A is here, A is 1. Right? And if A is greater than 1, we know it could be stiffer. If A is less than 1, which between it will be less than 1, so between -1 and 1. For example, 1 over 2, -1 over 2, something like that. Then it could be less than. Right? Remember, the A value is nothing over here, but it's just the lead coefficient over here. It's just one of the part of the transformation we already learned, right? And if it is if the A value is greater, remember transformation of A times fx. A is greater than 1, we know this could be elongated, and if it is less than 1, between 0 and 1. You remember between 0 and 1, if it could compress down vertically, right? It's going to be opening up. Okay, that's this transformation concept we already learned in college, right? Okay, and another information about the parent function or sine function is, just imagine if you go ahead and subtract by 2 pi, right? It's gonna be you're gonna move it to you add. I'm sorry. You're gonna subtract. You when you subtract by the argument, you can move to the right. When you add, you move to the left. When you move to the left, you're gonna have this part, right? You're gonna have, just imagine you're gonna have like this. I think I'm gonna just go ahead and let me go ahead and draw with the dash line so that you can see. So you're gonna have more something like that, and you're gonna have more something like this, and you're gonna keep going to have like that, right? And over here you're gonna have something like this. Okay, and you keep going up like that, right? And then keep going. Okay, and imagine this is the part right over here. The part over here you see that it is the part down here, the part over here is symmetric about the origin, right? And it just imagine if it is symmetric about the origin, what kind of function is that? If it is symmetric about the origin, we know that it is an odd function, right? And this is one of the concepts in college algebra. It's symmetric about the origin, it will be odd function. So sine function is an odd function. It's an odd function. And because this is an odd function, we know that a sine of negative x, remember? The odd function f of negative equal what? Equal to negative fx. So sine of negative x equal to negative sine of x. Because that's an odd function. Okay? So this symmetric. Okay? About origin. Okay. Alright, so that is the parent function of the sine function. Now, let's see if we can apply a transformation to this function. I mean, let's say we can move up or move down. We do some compression. Let's see what is going on. Okay, and we check if the domain and the range will be the same or not. Okay, or it's different. So P, B, transformation of sine function. Okay. So the sine function after transformation will be something like this. Let me see. I try to use different colors so that you can see that. You know what? I think I'm gonna delete it. Let me just rewrite with different colors. So I have blue this. Then let me use. How about if I use this one? Or maybe this. Okay, this one. There you go. This one better. We need to be colorful a little bit, you know. More fun, huh? So the function after transformation will be something like this: f of x equal to. So the a value, the amplitude here is not 1 anymore because the parent is 1. But right now the amplitude it is a. All right. Sine. Okay. Bx plus c. Okay. We just see the value. Move it to the right, to the left. And over here, this is remember the value inside. Here, this is like horizontal compression, right? Or horizontal stretching. You know, it's stretching and compression, but horizontally. And you add a k number over here. What does it mean over here? The k number over here, I tell you, like, is the function is to be will be moved up or down. Right? So this is vertical shifting right here. Okay. Right. So what is going to be the period when you have a function like that? When we have the b value, see the b value in front of the x over here is 1. But now we have the b value. So the period, of course, will be different. The period now will be can be calculated by this formula: 2 pi over b. All right, that's a period. Graphically, okay, I'm not talking about the time, because the time will be the same thing. Okay, this is the formula. This is it's fixed right here. This formula is now changed to 2 pi over omega. So depending on how fast the particle was moving in circular motion. Okay, but how many units is shifted to the left or right? Because in this case, we know it's not shifted because it's only the white part here, but it's now shifted. So in order to find how shifted, we call it phase shift. Okay, phase shift. And phase shift can be calculated by set this equal to 0, so it can be negative c over b, right? Let me see. do this way. So you set it to 0. So x equal to negative c over b. Okay, so how you shift it? This is the horizontal shifting. If your x value is positive, so we know we shift it to the right, but negative is we shift it to the left. So it depends on the c and b value. Okay. Okay. And the k value we know this is a vertical shifting. All right. Good. All right. So there's another the b value over here. But the thing is, I know that in college time we mentioned the b value inside the argument. We said it's a horizontal compression or stretching. However, because the sine function is we already, when we evaluate the period and the a value, we know that how much is stretching and compression horizontally already, especially after we calculate the period. So we don't have to worry too much of the b value anymore, because the b value is a part of the period already. Okay. Okay, so you don't have to put into the consideration horizontal stretching and compression, because when you calculate the period, they already do the stretching or compression horizontally for you. Okay. All right. Now let me give you the example. This is too much theory now. Okay. Example number 1. Okay. You know what? I think I'm gonna use a different. I think you can use different color. I think I'm gonna start with just white first. Okay. Now I'm gonna go ahead and sketch the sine 3 sine function, and I let you you see the difference between the graph among the graph of the sine function. Okay. First of all, I'm gonna go ahead and sketch the sine function for one revolution, which is 2 pi. Okay. Okay. So it's gonna be something look like we already had. It's gonna be something like this. Okay, let me sketch that. Okay, so I'm gonna use the white color here. Okay, so there you go. This is the sketch, the graph of the sine function. So this is f of x. F of x equals sine of x. Now I'm gonna go ahead and sketch the one with so this is one, you know, I think I should put the one smaller. I think I should put one right here. Yeah, I think it's better because I'm sorry. Okay. Okay. So it's 2 pi. So I think I'm gonna put this is 2, and this is 1, -2, -1, and maybe a little bit longer, huh? Oops. There you go. So this is y, this is 3, and this is -3. There you go. So first of all, I'm gonna get f of x equals sine of x, so it's gonna be something like this, huh? Because the a value is 1. Okay, a value is 1. Now then I'm gonna do with with another one. When a value is 3, you use a different color. So when a equals 3, so it's also the same thing. Okay, so it's gonna be something like that. Okay. Alright, so it's a equal 3. So this is f of x. F of x equal to 3 sine of x. So you see the a value. The a value will tell you this it is elongated, right? Okay, it get longer vertically. Alright, but the period is still 2 pi. Because the period is 2 pi over b, and all the b over here is 1. B is 1. This here is 1. Okay, b is the value in front of the x. Okay, so which is 1. Okay. And let me do another sketch when a is less than 1. How about a is 1 over 2? Huh? A is 1 over 2. So 1 over 2 will be over here, huh? There you go. And 1 over 2 will be here. There you go. So this the red one will be f of x equal to 1 over 2 sine of x. Okay. The period, again, the period is still 2 pi because the b is 2 pi over b. B is still 1. Okay. You just change the period when you have different b value. Okay. So that's how you sketch the sine function. Now, on the second example, I'm gonna help you to sketch this. I'm gonna help you to sketch f of x equal to sine of 2x, sine of 2x, sine of x over 2, and let's see what else. Sine of x over 2, sine of 2x. Okay. And the sine of x. Okay. So the difference between this and this is that you see the b value is different. For this one, it's kind of the same because it's the parent one. Okay. So we always want to sketch the parent one, and we apply the transformation, but we need to find out the b value, right? The period, I'm sorry, the b value and periods. So because we got the b value, we can get the period. So the period for this will be 2 pi over b, which is the period is pi. Okay, for this one, and over here the period over here will be 2 pi over b, so we 2 pi over a half, right? It will be 4 pi. All right, so the period is different, and because the period is different, it could be compressing horizontally or stretching horizontally. So you don't have to worry about the b value in front of the x anymore, which is because the b value in front of x we already used to calculate the period. Okay. All right. So I'm gonna go ahead and sketch them. Over here, if you notice the a value is all the a value is 1, so that's good. So it's not stretching vertically or compressing vertically. Okay. This is stretching horizontally and compressing horizontally only. Okay, so I'm gonna just go ahead and then let me sketch the parent one first. So the parent one is 2 pi. Okay, so pi here, pi over 2 here, and 3 pi over 2. Okay, I'm gonna use the y color. So I think I'm gonna use the y color for this. Alright, so we start with the a equal to 1 because that's amplitude is 1 for all of this. So you can see it's going to be something like that. Alright, then go all the way down here. And go up. There you go. There you go. It's kind of hard to sketch with this one, you know. There you go. So this is f of x equals sine of y. Now the period for this, and now let's sketch to one sine is fx equal to sine of 2x. The period is pi, so it is smaller. So the period is smaller. So it means, let me use this. Let me use a different color here. It's smaller. So one revolution is just from 0 to pi because the period is pi. So we gotta keep divided. And now it's gonna be something like this. Kind of. Here you go. There you go. It's all the way down. So up here. All the way here. There you go. Alright. So that's the red one. That's this f of x equal to sine of 2x. Because the period is only pi. So one revolution. Only pi. But now the period over here is 4 pi, so you gotta double them, right? So you gotta double. So there's 2 pi, 3 pi here, and 4 pi here. 3 pi here, 4 pi here. 2 pi, 3 pi. Alright, so it's gonna be here and here, right? Alright. So the period is 4 pi. The period is 4 pi. So half of 4 pi will be 2 pi. So we're going to use a different color here. So it's going to be something like that. Huh? Alright. Because one revolution is 2 pi. There you go. I'm sorry, because of the revolution is 4 pi. Alright. So you see the difference between the blue, the green, the red, and the white. Okay. One is kind of compressed horizontally, and then the other one is like stretching horizontally because the b value. The b value inside the x, inside the argument will be big difference. Okay, but the a value over here will be the same. So the a value is always go from -1 to 1. Alright. Now let me help you to sketch another one. Sketch fx equal to, this is more complicated. It's 2 - 2 over 3 sine pi over 4x. Okay, so I'm going to sketch this. First of all, we need to find the period. Period is very important. 2 pi over b. So the b value over here is pi over 4. So it will be 2 pi over 4. It will be 8. Alright. So that is one revolution. That's one revolution. Graphically, that's one revolution. Alright. Okay. Okay. So the period is 8. So I'm going to just go ahead and mark 8 over here. And the amplitude is still 2/3, so it doesn't matter. I'm going to mark over here 2/3. It's not a big matter. It doesn't matter. It's still 2/3 here. So here will be negative 2/3. So half of the period will be 4. Alright. So usually it's going to be something like that, right? So we have this. So we're going to have something like that. Alright. So all the way down here. Alright, however, that is for the function without the minus. So this is actually this is just 2 over 3 sine of pi over 4a. But because we have negative in the front, what does it mean? Negative in the front means you gotta do the reflection about the x-axis. So you gotta do reflection about the x-axis. So now let's make a reflection. So this will be down here. Okay, and this will be up here. There you go. So this is f of x equal to negative 2 over 3 sine of pi over 4. Alright. So this is nothing but transformation concept. All right, example 4. Move this a little bit up. Sketch. This is more complicated. Sine, so we have a value. We have, oh, look at that. All right, -1. Of course, when we do like this, we you gotta keep going because there's no boundary here. They did not say that how many revolution. Okay, if the question asks you to draw 3 revolution, you gotta keep 3 of them 3 times. Okay, you gotta repeat it. Okay, so depending on the question. Over here, all the graphs so far have been doing for you is just 1 revolution. Okay, 1 revolution. Same thing over here. I just want to do 1 revolution. If you want to do more, just add more. Okay. Yeah. Alright, so again, we're going to find b is 2 pi over b. So it will be 2 pi over 4. It will be pi over 2. Pi over 2, yes. So this is mean a period. 1 revolution is just pi over 2. Now let's see the phase shift. Okay, phase shift is 4x plus 5. I mean, how many units we move it to the left or to the right, right? So this is x equal -5 over 4. Look like we gotta move it to the left. 5 over 4 unit. Oh, I'm sorry. This is pi. I'm sorry. Pi over 4. I'm sorry. This is pi, not 5. Pi. So we gotta move it to the left. Pi over 4 units. So we're gonna do transformation 1 by 1 like that. Okay, but first of all, let's sketch the one with period. With period is pi over 2, and amplitude is 2. So amplitude is 2. Alright, so amplitude is 2. So there's 2 right here, and this is -2. Period is pi over 2, so I just mark everywhere. Doesn't matter. This is pi over 2, so half of that will be pi over 4, and half of that will be pi over 8. And this one you can calculate if you want it, which is pi over 4 plus pi over 8, which is 3 pi over 8. Okay. So let's do 1 revolution first. So I'm gonna use the y1, 1 revolution with amplitude is 2. Okay, and period is pi over 2. That's 1 revolution. Now we're gonna shift it to the left because it's minus. So you gotta shift it to the left. Pi over 4. This pi over 4 is from here to here, right? So let's see. Shift it to the left. Shift it to the left. So this one, move it to the left. You know what? I think I'll make it longer a little bit here. So this is -pi over 4. And this one will be -pi over 2. Okay. Now we're gonna shift it to the left. Alright, let's move everything to the left. Move everything to the left. So this is move it to the left. So this is become this, huh? Alright, this become that. This one become this. Just move pi over 4, okay? Move pi over 4. So it become this. Alright. And the part over here, so we come down here. Alright, so this is after we move it to the left. So this is nothing but y equal to 2 sine 4x plus pi, okay? And the y1 is just y equal to 2 sine 2 sine pi over 2 pi 4x 2 sine 4 2 sine 4. Okay. All right. Okay. Now we we're missing this -1, so we gotta move down 1 unit. So let's move down 1 unit. Let's do this one. Move down 1 unit. Okay. So move everything down. So this is 2, so 1 right here. So this is go down here. This is go down here. So it's going to become like that. Alright, so move down. So and move everything down. And move everything down. Alright. So the red one will be the final one. So what will be 2 sine of x for x plus phi plus pi. Okay. Minus 1. There you go. So that's how you see it. That's how you do transformation concept to sketch the sine function. Pretty easy, huh? Very easy. Alright. Okay. Okay. So that's all for sine function. Now on the second part, let's see how we're gonna graph the cosine function, and let's see the domain of cosine function and the range will be the same as the sine function or not. Okay. Okay. Second one, sine cosine function. Oops. How come this all of my colors over here just disappear? Oh. Okay, I'm sorry guys, I need to change a little bit. So all of my color is just gone. Okay. Okay. I'm sorry guys. And this one I should go for the brown. Red? I think red is good. Right? Let's check with the red colors. Let's see how good it is. Yeah, that's good. Not that bad. But I think I need to put this here you go, like that a little bit. Alright, so second one. Alright, cosine function. Alright, and again we're gonna split into two parts. The first part we're gonna talk about the parents of cosine function. I think this. Parents of cosine. Oops. Parents function. Okay. So the parents function could be something like this: f of x equal to cosine of x. Or we write like this: cosine x. Okay. Alright. So let's box them. I don't know, this red color is good or not. Maybe it's still not good, huh? Maybe this one. Okay. Alright. And again, this the x over here will be in terms of radian or degrees. Everything could be the same. And let's see the sketch of cosine side will be the same or not. Okay, so go ahead and sketch it using the table. Okay. Okay. Let's use the table. So over here we have x. We have cosine of x. So when x equals 0, cosine will be what? When x equals 0, cosine of 0 will be 0, right? So cosine of 0 will be, yes, when x equals 0, cosine of 0 is 1. I'm sorry. Alright, when x equals 0, cosine of 0 is 1. Okay, 0 the radian I'm talking about, okay, or degree if you want to. And when x equal to power 2. Maybe let's see what happened when x equal to power 2. And cosine power 2 will be what? Cosine power 2 will be 0. How about when x equal to pi? Cosine of pi will be what? -1, right? Cosine of pi will be -1. How about 3 pi over 2? Cosine of 3 pi will be 0. And 2 pi is 1. Okay, based on this table, I can go ahead and do the quick sketch right here. Okay, let's go. Oh, okay. Alright, do a quick sketch right here. So over here again, I'm gonna just go ahead and draw one revolution, so just 2 pi. And this is pi, and pi over 2. And this is 3 pi over 2. Because this parent function, the a value which is 1, so they also have amplitude. The amplitude is still from -1 to 1. It just the amplitude is just 1. Yes, okay. Okay. The range is the range is always go from -1 to 1. And when it's 0, so we're gonna start it from here. Okay. Instead of from here, so we're gonna start it from here, and at pi will go all the way down here. So we're gonna be something like this. Okay. So go all the way down like that. Up here. And go back up. Here you go. So this is the sketch for one revolution of cosine function. Okay. So again, the p is still here. The period will be still 2 pi. Okay. The domain is still go from negative infinity to positive infinity, because this is just one revolution. It just go to revolution for revolution. So they keep going to the level to the right, and the range is always the same. We go from -1 to 1. So we see basically kind of the same as the sine function, right? And what else? If you notice, if you go ahead and flip this one over the y-axis, just because there's another part right over here, right? And there's another part right over here. Just imagine I have something like this on the other side, right? Right? Have something like this on the other side. Okay. And you see that this is nothing. The green one and the white one is kind of symmetric about the y-axis. And when it's symmetric about the y-axis, what is happening? What is symmetric about the y-axis? We call that an even function. Remember? So that's why we have over here cosine of -x equal to cosine of x, because it's even function. Okay, so it's even function. Remember the concept of an even function is the property f of negative equal to fx is even function, and in that case it's gonna symmetric about y-axis. Okay, symmetric about y-axis. Okay. Okay. What else we know about a cosine function? Again, the amplitude is still equal 1. Okay, because it's parent function. Okay, so a over here always 1. Of course, a could be changed if we apply the transformation into that, right? Okay, so that's the parent function. Now let's apply the transformation into that. Transformation. All right. So if we apply the transformation into that, my function will be something like this. F of x equal to a, right, cosine bx plus c plus k value, huh? Plus k value. Alright. So in this case, the period will be 2 pi over b. It tells you how much is shrinking or stretching horizontally. And the phase shift, you're gonna calculate the same way. So phase shift will be bx plus equal to 0. So x equal to -c over b, and the k value again. The k value is tell you how much is going up or going down. Okay. Now I'm going to go straight to the example. Let's see. So in this example, because you see the cosine and sine function is kind of the same, so I'm not going to give you too many examples like last time I did. I'm going to give you this one, and I want you to sketch in the certain restriction. So I'm not going to just go ahead and sketch in one revolution anymore, but so it depends on how much the question asks us to sketch. So this is sketch y equal to 20, so the amplitude is pretty big. Cosine pi x minus pi over 2, and I want you to sketch between negative 1 and 3. Okay, for negative 1 and 3. Okay, not for one revolution. Actually, we always want to do one revolution. When we do, then we apply transformation and we put the restriction between negative 1 and 3 only. Okay. All right. Let's see. Again, first thing you gotta do, you gotta calculate the period. So 2 pi over b, which is just 2. The period is 2, and we calculate the phases. So pi x minus pi over 2. Okay. Put it 0, so x equal to half. Here you go. Okay. All right. So now let's do. So this look like this is we're gonna move it to the right. Move it to the right on half unit. Okay. So first of all, we always start with the parent function when the period is 2. Okay. When the period is 2. So this x. Over here, this is 2. Alright, so this is 1 right here. The amplitude is 20, so it doesn't matter. I can mark over here 20 and over here negative 20. Okay, now we're gonna do the cosine. So the cosine has the V shape. Okay, so we're gonna start from here. So we're gonna go up here. So it's gonna be like that, right? So all the way down here and up here and up here. Alright. I'm sorry, this terrible graph, but it's kind of hard to bend it when I do on the tablet. Alright, so that is one revolution for cosine. So this is like this is 20 cosine cosine of pi x. Okay, and now we're gonna shift it everything to. Now we're gonna shift it. We shift everything to the right a half unit. So this is a half right here, right? So we shift it to the right half unit. All right, let's do to the right half unit. Let's see, I can use different color right here. Okay, so I think we can use this one. Half unit. So right now it's gonna be here, right? So let's move everything to the right half unit. So it's going to be something like that. So then we're going to move down, up, and a half unit will be here. So here will be over here is the 1, 2. This is 3. So half over here will be 1, 2, 3. So this is between 2 and 3. Okay, so it's just a half unit. Okay. So this value here is 2 plus a half will be a 5 over 2 right over here. Okay. Time with 2 there. All right. But what they wanted to sketch, they wanted between negative 1 and 3. So it means that we gotta keep going because that's what they want. They want from negative 1 and 3. So over here, let's do the other side. Negative 1 is on the way to the other side. So this is negative 1 right here. It's negative 2 right here. So they want it from here. Okay, so they want it from here. So we're gonna use again. We're gonna use. I'm gonna use different colors. So let's see. I think I'm gonna use this one. So we're going from -1 to 3. So -1 over here, right? So up here is this one. Okay. So right here, I want to add a little bit more. So -1 down here. Alright, and 3. So all the way over here. There you go. Alright. So the final sketch will be the yellow part and the green part together. Both of them. Okay, the yellow part and the green part. So okay, so final one will be y equal 20 cosine pi x minus pi over 2. Because they want between -1 and 3, so they want it between here and here. Okay. Okay. Alright. Like that. Alright, so that's your final sketch. Okay, it's not really that bad. Okay? Now that's the first example. So now in the second example, I want you to go ahead and do it yourself. Okay? Try to mimic and try to do it yourself. So you have 3 cosine pi over 2 x minus 1 over 2. Alright, go ahead and do it yourself. Okay? And after you do finish, if you have any question, then you can then you let me know. Okay, we can discuss this more about this. But I want you to figure out this problem yourself, because see, all the transformation concept for sine and cosine function is the same. So I'm gonna let you guys do this yourself. Alright? Alright, so I think I'm gonna stop right over here. Hopefully next time we have time, we're gonna talk about tangent and cotangent. Okay, I'll see you next time. Bye bye.